Hey guys, Buildzoid here with another PCB breakdown for you. Today we're going to be taking a look at the Nvidia GTX Titan XP. So that's the new Pascal Titan X, because apparently there's not enough, letters to use. They ran out of letters or numbers or whatever, So, yeah, so we have another Titan X. Apparently they dropped the GeForce name, but that's still stuck on the cooler. So, yeah, that's great. Either way, we don't really care about all the naming conventions. What you're here to care about is the PCB. And I'm very happy to announce that I know for a fact that I found Nvidia's voltage controller of choice. I have a datasheet for it, so we will be covering Vcore volt mods for this card, which is great. And then you're going to find out that the card actually does catch fire when you push it really, really, really hard. So I do recommend that you get an e-power if you know how to use an e-power and want to use the card on LN2. Though, surprisingly enough, I also noticed a detail that I missed the last time I was reading the datasheet for these Mosfets. So I used to bash the Nvidia VRM super hard on the 10 series so far, just saying they're completely crap. Well, luckily, this new the detail that I now noticed, and I'm very sorry that I didn't notice it earlier, means that they're not super crap. They're just, kind of they're a little subpar as far as I'm concerned, but it's not, oh my god, this is going to instantly catch fire levels of crap that I thought it was before. So then, let's take a look at this card. First of all, let's identify all the VRMs we have here. So this thing right here is all core voltage, and that goes, and I'm including the driver FETs, well, driver ICs, not driver FETs, because there's two FETs in a driver. We'll cover that eventually. So that's Vcore, right there. Then up here we have Gddr5 X Memory. And I'm not sure how that VRM is actually laid out. So that's going to be a bit of a problem, because we have 2 of these and 3 of those, and as far as I know, there's only 1 voltage controller for that whole VRM, so I'm not really sure how that's supposed to work whatsoever. I mean, so, yeah. Because I don't think it's a real, it can't be a 3-phase, or, well, it could be a 3-phase, but I really doubt it's a 3-phase, because nobody makes a 3-phase memory VRM, but it can't really be a 2-phase either, because there's 1 MOSFET too many. And I guess it could be a 1-phase, where you have the 2 inductors in parallel, except that's dumb. That's just dumb. Nobody does that. Why would you do that? So, yeah, I'm a little bit confused about that one, but luckily Gddr5 X is so low power that it doesn't super matter if I don't know how that works, and I'm not going to tell you how to volt mod it. So, I'm not too concerned about you missing information that could potentially protect your card, because you can't really break it, unless you can find your own datasheet, and then that's not on me. So yeah, I basically don't know how this memory VRM could work. If it is a 3-phase, then it can do, well, then we'll cover it later. So, yeah, warning about that. The other warning you need to understand is I have no idea what these FETs well, I have a suspicion what those FETs are. I am not 100% certain that they are what I think they are, because I still haven't seen a photo where I can actually read the labels on them. So that's very unfortunate. Luckily, Nvidia has decided that for the whole 10 series, they seem to be using the one MOSFET and just using more or less of it, so I guess they got a really good bulk discount on it. And so they're using the 4C85N from On Semiconductor. They're using that on the 1060, the 1080, the 1070, so I guess they must be using it on the Titan X as well. It comes in this package. It looks basically exactly like this, but there's a lot of MOSFETs that look exactly like this. But I'm just going to assume that this is the MOSFETs they're actually using, because I don't see why they would use any other ones. These are perfectly adequate in this VRM setup. So yeah, so that's a bit about the Vcore. That's some words of warning here. Other than that, the Gddr5 X, for those of you who aren't aware, requires a PLL voltage. So basically that's an extra voltage that you wouldn't need for Gddr5. And that is probably here. It apparently doesn't do anything for overclocking, and I have no idea how to, volt mod it, because I don't have the card, and I can't get that much information off of the internet. And this over here is also a VRM of some sort, but I don't know about enough about Nvidia cards to actually tell you what that does. So I'm very sorry about that, but we'll just cover the Vcore part, because that's the most important one anyway. So yeah, let's get on with the Vcore. So Vcore, as you can clearly see, is 7 inductors. Right? So 1, 2, 3, 4, 5, 6, 7. The problem is, well, not the problem. Nvidia has done this before. It does seem to have 8 phases somehow hooked into it. They've done this before. They had a 6 inductor, 8 phase on the Titan X, the original Titan X, the older Titan X, the 980 Ti, and the Titan Black Edition, and the 780 Ti. Those were all using a 6 inductor, 8 phase, and I don't know how you can actually do that layout, but it's doable. It's very, very doable, and there's not really any issues with it as long as your inductors can handle all the current, and you basically get free current handling capabilities on the side of your Mosfets because, well, there's more of them. So they can handle more current because you can spread the current across more Mosfets. So that's that. So we have 1, 2, 3, 4, 5, 6, 7, 8 Mosfets in here. These are NTMFD4C85Ns from On Semiconductor. Nvidia, well, again, as I covered earlier, I think that's what these are. I'm not 100% certain because I haven't seen any full, perfect confirmation, but that's what these should be because that's what Nvidia has been using all the time. They look like this, and it doesn't make sense to me that they would use a different MOSFET just because, they have an 8 phase. So using this MOSFET, they're still perfectly good. So, one thing to note is I've recently discovered that I missed a very important part of the data sheet for these MOSFETs. These do come with a case temperature rating. Unfortunately, that case temperature current rating is only at 25 degrees. They're not like international rectifier where you get a 125 degrees rating as well. But generally, by 125 degrees, the higher quality MOSFETs will only derate by 50%. However, we also have an ambient temperature rating, and the ambient temperature rating is basically the MOSFET sitting on a PCB without a heatsink, and I'm not sure about the airflow specifics, but it's basically not cooled at all, and it gets stupid hot. And I think the ambient temperature ratings generally correspond to around 100 to 125 degrees, and that rating is at 25 amps. So, yeah. At least when they're cooler, you can expect them to handle, 40 amps per phase. I think up to 85 degrees, maybe up to 70 degrees, you can expect them to do 40 amps on the high side for every single phase. There's 8 of these, so that gives you a total of 320 amps. That might sound like a lot, considering that this is a 200, this card has an average power draw of 200 watts and a peak power draw of 268 watts. But do keep in mind that these things run at extremely low voltage. The Titan X runs at 1.05 volts. It needs around 255 amps at peak power draw. So you start with a card that has 250 amps, 200 to 250 amps current draw. If you start overclocking this a lot, you can very, very, very quickly hit that 320 amp current limit and blow out your VRM. So while this is not a catastrophe, this is actually way better than I thought it was, it's still pretty bad. Because before I thought it was instantaneous fire, now it's just like there will be a fire if you push it really, really, really far. So my recommendation when overclocking this card is do not raise the core voltage beyond, 1.15 volts-ish, maybe? I personally wouldn't feel safe doing that either. And if you are going to be raising the core voltage, I recommend you get a heatsink on the VRM, a big heatsink, and get a lot of airflow. Because if that VRM gets too hot, you just destroyed a $1,200 graphics card. You should feel pretty bad about yourself. So, yeah, that's sort of that with the VRM. It's not a catastrophe. It'll definitely handle gaming loads and, whatever kind of daily overclocking stuff. But if you do raise the core voltage, Well, you better cool it pretty well because those current ratings aren't exactly super promising. The high side is certainly like, well, that 320 amp current rating for the high side of this VRM is just, that's the combined capabilities. And that's actually like the bare minimum. You could probably push a little bit more than that because this is the high side we're talking about. The high side doesn't spend a huge amount of time turned on at any given moment, and the continuous current ratings are continuous current. That means the MOSFET is on and conducting current for say 10 seconds, which is that's like a massive difference in terms of what it does to the MOSFET compared to say a 10 microsecond pulse of 50 amps, which is 10 amps above what they're rated for continuously, but that'll still be fine. So yeah, and even the datasheet, if you look at the pulsed drain current, there's a 300 amp rating for 10 microseconds for these MOSFETs. So you're pretty safe with overclocking these. Just don't push them super hard. I certainly wouldn't go over 1.2 volts, and I say maybe put like a temperature sensor in the VRM just to see that your thermals aren't going absolutely insane as you raise your Vcore. Because if your thermals start going up really quickly, that means you have a problem. The other thing that you could, the other way to tell if a switch mode power supply is about to fail is if the efficiency takes a dive, but you can't really measure that. So yeah, so be very careful when pushing it really far, because I will give you Vcore mods for this card, and I'd really appreciate it if you don't blow it up. Admittedly, I don't think anybody who actually watches my channel will buy one of these, so, I can feel decent about myself because probably nobody's going to break a card using my crappy VRM analysis video. But yeah, so this VRM, it's not incredible, but it'll probably be fine. I really don't recommend giving it too much Vcore. The other thing is the Pascal cards don't really scale with over 1.25 volts. They just, hardline. So for the sake of safety, I say don't push it too far. And more importantly, this card has massive power throttling at stock, and I think you'll see more performance gains from just removing the power limit and not touching the core voltages than from royally screwing with the VRM and risking that it actually catches fire. So that's your Vcore, and as I said at the start of the video, I have no idea how that memory VRM works. There's 3 FETs in there, so in theory it should handle around 120, 90 to 120 amps. This is the VRM. This is the VRM that powers the Gddr5 X. Gddr5 X doesn't pull a lot of power. I mean, there is a lot of it on this card. There's 12 gigs of Gddr5 X on here. So, it's going to pull more than the Gddr5 X on the 1080. But I still don't know how to, get memory voltage control. I don't know how much power Gddr5 X uses. And really, it's still a relatively low power device. So I wouldn't be too worried about the memory VRM if I were you. Plus, if you aren't raising its voltage, then we already know that Nvidia tests all their cards to not explode as long as you don't turn off the power limits, like I'll show you how to do, and don't raise the core voltage beyond what they let you raise it. So, yeah, I wouldn't be concerned about the memory VRM, and that's that. The PLLs and this thing right here, I have no idea, as I said earlier before. So then, power mods. It has recently come to my attention that what I said about power modding the 10 series is wrong. You can't just short all your shunt resistors however the hell you please. Because the cards do actually have a fault protection. Well, they do have a fault detection system, and if the card thinks the power draw is abnormally low because of your mod, then it won't go into 3D clocks. I've had somebody panic in the comment sections of my, get pretty stressed out in the comment sections of one of my previous videos about Nvidia cards because they actually soldered these things. So from now on, don't solder the shunts. Don't solder over them. That will not go very well. use Collaboratory Liquid Ultra to short them out, because first of all, it's easy to remove if you screw up. Second of all, the Collaboratory Liquid Ultra is not super conductive, like, well, not superconductive in the superconductor sense, but like it's not as conductive as soldering, right? If you solder over these with like copper wire or something, that's way more conductive than a thin layer of Collaboratory Liquid Ultra bridging the shunts. The other thing here is, if you are going to be shorting out the shunts, even with the Collaboratory Liquid Ultra, I recommend you short them one at a time and test the card in between each short. So say you get the card right and you notice that it's power throttling. So you short this shunt, you put it back in your system, you test it. If it's still power throttling, go and short another shunt. If it's still power throttling, short another shunt. Just do keep in mind that after shorting a shunt, if the power reading that the card sees goes too low, the card will not go into 3D clocks, robbing you of performance and basically making the card, it'll essentially look like the card is broken. If the card isn't clocking up when you apply 3D load, that means you've shorted out the shunts too heavily and it's detected that the current readings are wrong. So do keep that in mind, because that is a thing with these newer Nvidia cards. So then, voltage modding. Well, here's the, damn it, GIMP, gotta cooperate. Here is the back of the card. There's not really much of anything here. Interestingly, Nvidia has opted to stop using tantalums on the back of their core in favor of ceramics. I guess it's because they needed a faster response time on their capacitors, because all the tantalums and the and electrolytics, they're all much slower to respond to a current change than current demand changes than ceramics. So, just an interesting point that I wanted to mention. So then, but we don't care about this part of this card. We only care about this thing. That is a UPI 9511P. Actually, it's not even 9511P. It's the UPI 9511, except if you actually look at the chip, it says 9511P at the end of it, but that's part of the order naming scheme. So the official name on the UPI website is just 9511. This thing is an 8-phase, real 8-phase. Yep, that's surprising, isn't it? It's an 8-phase, synchronous rectified buck controller. So this is Nvidia's new voltage controller of choice. I'm pretty sure this is the only one. No, this and the 9509 are the only two voltage controllers you will see on any of the new 10 series cards, because they're the only voltage controllers that support Nvidia's new power management stuff. And yeah, so these should be pretty much universal. So regardless of if your card is rebranded by Asus or MSI or whoever, you will still, these datasheets still apply for them. You just have to figure out if you're actually trying the correct pin. Speaking of correct pin, this is super, super easy, because, oops, old habits die hard. Accidentally open Paint instead of switching back into GIMP. So, voltage. So, bit of a problem here, because what you're going to want to do is you're going to measure your resistance from pin number 1. So, I already know which way this chip is oriented. I mean, you can't see it in this photo, but you want to short pin number 1, which will be opposite this pin. So it should be right there. That should be pin 1. And actually, you don't want to short it. You want to measure from that pin to ground. So measure to ground, right? Measure it to ground. So, well, that's the, give me a second, FB. That's the feedback pin for voltage. So you measure that to ground, and then from there, basically drop a comment down below, and I'll tell you what to do from there, because you need the resistance from ground, and then you basically put a potentiometer or a resistor, or it might even be pencil moddable. You put a resistor or a potentiometer between this and ground, and that will increase your core voltage, because the card where the voltage controller will effectively see a lower voltage than it's actually producing. So that's that. That's for Vcore. That's to increase Vcore. I will not cover yeah, there's no way to really mod power on this thing. Because, wait, let me check that there really isn't. Nope. So this thing has per phase current sensing like the newer international rectifier voltage controllers. So they're really this is the limit of what you can do. So just measure from that pin to ground and then apply a resistor or potentiometer of the correct size, and you'll get, 10% more, 20% more, however much more voltage you want, depending on what resistor you select. I cover this in a separate video somewhere on my YouTube channel. So yes, that's that. That's everything there is to say about the GTX Titan X. And yeah, I mean, VRM-wise, if you're going for LN2, I think at 1.4 volts, you'll definitely need an E-power, because the VRM is just not strong enough. So definitely don't go to 1.4 volts. At 1.3 volts, I wouldn't trust this VRM. At 1.25 volts, I'd be feeling pretty sketchy about it. 1.2 volts, it should handle fine. 1.1, 1.15, I think you'll be safe. Perfectly safe. Of course, every single mod I just detailed voids your warranty, and I am not to be held accountable for anything you do that breaks your graphics card. I am willing to help you out down in the comment section below, but, there's a limit to what I can do. So, that's that for this video. If you would like to see some other card, drop a comment down below. I am already building up a really long list of PCBs to do, and basically cards just sort of move around however I feel, what I feel like talking about. So if there's a very specific card you'd like to see, drop a comment down below and I'll try my best to do that card in one of these videos. If you liked this video, there's a like button. If you didn't like this video, there's also a dislike button. And, right, you need to subscribe to my YouTube channel, and if you haven't already, and do consider donating so that I may buy one of Nvidia's massive rip-offs one day. I'm joking. And that's that for this video, and see you next time, where I will actually be doing a video that isn't one of these paint videos, something more practical. So be excited for one of those. Yeah, see ya, guys. Oh yeah, and there will be a stream on Saturday. I've done stuff. Unfortunately, it'll be more Intel overclocking for anyone who wanted to see anything else, but yeah, that's that. So see you tomorrow or Saturday, depending on if I actually get a video done tomorrow. So yeah, that's that. Thanks for watching, and goodbye.